So for problem number 5, we won't go in great detail just because it's similar to the problem we just did. Sine of theta, we're going to create a triangle. Sine is opposite of hypotenuse. So we can set up the triangle. They tell us opposite of theta. The reference angle we'll use is 5. 5 is opposite of theta. Hypotenuse is root 70/4. You can't simplify that. Do Pythagorean theorem to find that last adjacent side, and we get 7. Just remember, when you set these triangles up, always then pay attention to direction. Okay, so to the left is negative, therefore it's going to be -7 for the adjacent side. Up is positive, so positive 5 makes sense. Hypotenuse always positive, so positive root 74. So just pay attention to the sign. Again, we did what we did in the other one. We first found sine first, opposite of hypotenuse. We rationalized by multiplying by radical 74, and then we get 5 root 74 over 74. The 5 and 74 in denominator don't simplify, so that's our final answer. Remember, always do sine, cosine, and tan first. Once you get those original ratios, flip them right away. So for sine, when we flip the original, we get root 74 over 5 for cosecant. For cos, we get -7 over root 74. We flip it for secant. For tan, we get 5 over -7. For cotan, we flip it. Okay, and then for the ones that have radicals in the denominator, just like cosine also has radical in denominator, we rationalize by multiplying by root 74 over root 74. Then we have -7 root 74 over 74. -7 and 74 have nothing. They're both divisible by, so we are done. Now the reason this next one's a little bit harder is we have to pay attention to our restrictions. So they originally say that tan of theta, the triangle that we're going to make, where opposite is 12, adjacent is 5, right, is positive. Now we know that all students take calculus, right? And so that stands for the signs. First quadrant, all signs are positive. The S in quadrant 2 means sine and its reciprocal. Cosecant are the only ones that are positive. Everything else is negative. The T in quadrant 3 stands for tan, and cotan are the only ones that are positive. And C stands for cos, and its reciprocal secant are the only ones that are positive. So if right away they say tan is positive, we know that the only two options are quadrant 1 and quadrant 3, because tan is not positive in quadrant 2 or quadrant 4, so those are out. We then look at our second restriction. It then says sine is less than 0, meaning sine is negative. So if we're down to quadrant 1 and quadrant 2, if sine is negative, we can't be in quadrant 1, so the only option is quadrant 3, where both tan is positive and sine is negative. So then in quadrant 3, that's where you set up your triangle. And then the rest is the same as the last problem we did. And I'm not going to go through the rest in detail because it's like last problem. You first find sine, cosine, and tan using your triangle that you created. Just pay attention to the signs. Once you make that triangle, even though you originally know that tan of theta is, it looks like positive 12 over positive 5, and you know 12 is opposite and for TOA, and 5 is then adjacent. So when you say theta, you know that the opposite side is the 12 side. You know that the adjacent is the 5 side. However, you need to put in negatives in front of those numbers, because as we move to the left, we have a -5, and as we move down, we have a -12, and the hypotenuse is 13, always positive. So that will impact your answers if you don't pay attention to the direction and include those negatives. And then again, using SOHCAHTOA, we use our triangle. So if sine is opposite over hypotenuse, we look at our triangle. Opposite is -12. Hypotenuse is 13. And then if we need its reciprocal, we just flip the original. And the others are the same, using cosine adjacent over hypotenuse, and tan opposite over adjacent. And we always flip for their reciprocals.